Number 10 we have here, so this is 4.4 continued. Now we're doing our examples. So number 10 is about as easy as it can get. Y double prime plus 2y prime minus y equal to a constant. So not equal to 0, so it's not homogeneous, but you don't have a variable. You don't have t, or you don't have e, or you don't have sine or cosine. So I want us to identify things. So we want to identify f of t. So I like to write that down, at least initially. F of t we know is 10. So if f of t is 10, that tells me that r and m are both 0. And r is not a root. Because you would have had it equal to 0, right? If r is 0, then you substitute in, you would have 0. So that's one of those trivial cases, and it can't work because it's not set equal to 0. Okay. So that means we choose S. I'll just say it's not really chosen, it's just that's what S is. So S equals 0. Then y particular of t is equal to a naught. All that other stuff is gone. So if you come back here, or all of this whole thing, let's see, mostly just that, I guess. So we have basically just a constant. So this is 0, this is 0. And so if that's the case, m is 0, that means s is so, and it's not a root. So 0 is not a root. So s is 0, so you just get, so this is your particular solution, this whole thing. And then that's 0, that's gone, and you're left with just that, just a naught. Okay, so particular is that, and then so substitute into the given. So this is what that process didn't show you what to do. So now you want to substitute into the given equation. So if that's y, then, and you take the derivative of a constant, you get 0. But that's literally what you're doing, though. You're putting in a naught and taking its double prime plus 2a naught prime minus a naught equal to 10. So of course, when you take that those derivatives, you get 0. So you get that a naught is equal to negative 10. So that's your particular solution. So thus, y particular of t is just negative 10. So that is a particular solution. So that's what you're basically going to do, is find the undetermined coefficients piece of it is basically finding what these coefficients are, because the rest is the variable part. So you'll substitute it and solve a system. Or just an equation like that, because it's kind of easy. Okay, number 14. We have 2z double prime plus z equal to 9 e to the 2t. So solve that. We can see, let me go and change it up color-wise just to make it a little nicer. We can see that m is equal to 0, and your auxiliary equation is 2r squared plus 1 equal to 0. And so that has imaginary roots. So your r ends up being plus or minus I root 2 over 2. So subtract the 1, divide by the 2, you square root, and then rationalize. Okay, so it's got those. So 2 is not a, so those are imaginary. So 2 cannot be a solution. So this is a little confusing when you use this auxiliary equation and you say your roots are r, and then like you're calling that r as well. So you're saying r is 2. Well, no, r was that. So you got to be a little careful there. You maybe change your variable. I don't know, change it to z or something, or w. But this is your r. So I'll go back and I'll say r equal to 2 is not a solution. So then that tells you what the algorithm what to do. All right, so then we have z, don't use z over there, by the way. Z sub p is a naught e to the 2t. So what case was that? Let's go back. Again. So we had basically this case here. So that's a 2, and then this was 0. So let me show you again. For 14, what was it? It was 9e to the 2t. So s was 0, right? So coming back, or I'm sorry, m. M is 0, so it's just a naught. So that's all you're getting. Okay, so that then is your particular solution that will solve for a naught. Okay, so now substitute and solve. Going back to the original, then, it's 2 times the second derivative of that. So with e, it's just you do the 2 twice, so it's 4 a naught e to the 2t, which, right, makes it kind of nice, plus a naught e to the 2t is equal to 9 a naught e to the 2t. All right, so then we solve that for a naught. So, and solve for a naught. So you'll notice that let's see, so 8, so well, actually, be careful. This is 8 plus 1 is the 9, so that's equal to the 9 e to the 2t, so that would imply what? That would imply a naught is equal to 1. So that's it. Okay, so that's your solution. So therefore, z particular solution is equal to just e to the 2t. Okay, and you can check it. All you got to do to check these solutions is substitute back into the original. Okay. 16, 18. Okay, let's do another one. 16. This one's a little long. We'll go on to the next page. So number 16. So they use theta. So theta double prime of t minus theta of t is equal to t sine t. Okay, so that's what's given. So from that, that's your f of t. We can see that beta is 1, alpha is 0, and m is equal to 1. Okay, then r squared minus 1 equal to 0 if and only if r is equal to plus or minus 1 in this case. So not complex. In this case, then we have what is our S? So is R going to be a solution? So S is equal to 0. Let's see. So my R, let me go back here. My R back to here. Yeah, so this is not a solution. So alpha plus beta I is not a solution, so we're using S is equal to 0. So if you go back to here, here's your alpha beta. So basically I'm then saying we know what the solutions are. So S is equal to 0 since 0 plus I is not a root of this, because the roots are 1 and negative 1. So that means that the solution is theta particular of t equal to, now you write out that polynomial, which is a1 t plus a naught cosine t plus b1 t plus b naught sine t, just substituting in to that solution. Okay, so now comes the algebraic crunch time here, is you have to take the derivative of theta of t twice. So now we're going to do theta of p prime. And when you do that, you need to use chain rule. So it becomes rather long. So I'm going to, try that. Okay, so try that, and then so do both of them. And then I'm going to go ahead and substitute in because it takes a while. And it's really not that bad. I mean, you just got to do chain rule with t. Okay, so I'm going to go ahead and paste it in. You'll see everything here when I copy it over, but still, work it out. Okay, so all that's your prime. All right, so your solution's there, and then that's what you get when you do the derivative of theta twice. So then you substitute that into, so you needed the first derivative to get to the second. So you need this to get to the second because you're going to be substituting into this. So now let's substitute into that, and and then you get this next step. Okay, so you're going to get all of this, and then you solve it. So here you're doing all of this minus all of this. Okay, so that's this step right here when you're subtracting them, that whole thing. So you subtract, collect like terms, factor out cosine, factor out sine. Okay, well that's this. Okay, then when you subtract them, you're doing all of this minus all of this, and then you have to do the same sort of thing. You're gonna collect everything to where you have cosine, cosine, sine, sine, and sine, and now you equate coefficients. Because you're setting this right-hand side was the given initial equation, so you're setting these coefficients equal to what this needs to be. So that's all of this. So negative 2a1 is 0. This has to be 0, so the negative 2b1 is 1. Okay, and then you solve. So you're solving this system. Those are what we mean by undetermined coefficients. So with all that, we get this particular solution. Therefore, theta p of t is equal to negative t sine t plus cosine t all over 2. By determining what a1, a0, b1, and b0 are. So this might take a little bit to do. I wanted to get to more examples and not work through. That would take probably half an hour to do that thing. Okay, let's look at 18, and then I'll copy over 24. So 18 is a little shorter. We'll see what type it is. This one's equal to 8e to the t, so it's that type with the e in it. Y double prime minus 2y prime plus y equal to 8e to the t. So we can see here no t terms, so m is equal to 0. We have for our auxiliary equation r squared minus 2r plus 1 equals to 0. And that is actually a double root. So this is the double root case I wanted to show you. So r equal to 1, obviously repeated. In particular, it's double root. So that was the case above that had a double root. So s is equal to 2. All right, so if s is equal to 2, then we know what our particular solution is, and then we go and solve for a. So particular, y particular is equal to a t to the s e to the t. So then that's s is 2. So it's a t squared e to the t. Then do its derivative, do the prime, and you get a t squared plus 2t e to the t using the chain rule, and then refactor y particular double prime a t squared plus 4t plus 2 e to the t. Again, chain rule, factor, etc. Now substitute to solve and equate coefficients. Substitute and equate coefficients. That's the concept that you've seen before, one way or another. So you get a t squared plus 4t plus 2 e to the t minus 2a t squared plus 2t e squared, right? I'm substituting directly into the function right here, and then I'm going to set it equal to 8e to the t. So where did I leave off? Negatives. Now I'm on the y. So plus y, which was just a t squared e to the t. And that is all equal to 8e to the t. All right, so now what you got to do is expand it and then equate coefficients. Well, there's no squared term over here. So what you're going to get is just 2e to the t equal to 8e to the t. That gives you what a has to be. Everything else is going to cancel out or be 0. So expand and collect. And then all you're looking at is 2a e to the t equal to 8e to the t. That's what the coefficient is. So what does a have to be? A has to be 4. So your particular solution then is 4t squared e to the t. And again, it would not be too difficult to just check that. Take its double prime, -2 times its derivative, plus itself, is that 8e to the t. Okay, so keep in mind what you're really trying to have. These are, I wouldn't say you can guess every time, but simple ones, if you knew kind of where you're heading, you could guess it. Okay, then the last one, again, a little bit of writing, a little longer. This is number 24. I'm going to go ahead and just copy it in. You can pause and take a look at it. So try number 24. Solution will be here. Oops, wrong button. And yes, we're ready to go on to the next section after this. This is quite a long chapter, actually, now that I'm doing it. Okay, so take a look at that, number 24. So try it, and then you have your solution right here. All nice and worked out. Okay, that'll cover, that finishes 4.4. We'll go on to 4.5 next. The superposition principle.